This video is CCBYNC. Welcome everyone. Today we're going to do the Pythagorean Theorem. And you can remember from geometry that the Pythagorean Theorem is a squared plus b squared equals c squared. I want to make it clear though, these are the legs. And the legs are always, each one is squared and they're added together. The opposite side, all by itself over here, is the hypotenuse. And it's always the part that's by itself. So even though we do A, B, and C, that's sort of the traditional way of doing that. You just have to remember it's leg squared plus leg squared equals hypotenuse squared. So we end up with the A squared plus B squared equals C squared. This triangle here is a pretty standard one that we'll have throughout the semester. It's uppercase and opposite is the lowercase. So the uppercase represents the angle, the lowercase represents the length of the side. So you can see C is opposite of C, B is opposite of B, and so on. So sometimes it's written like this. The first leg squared plus the second leg squared equals the hypotenuse squared. And we're going to go ahead and jump into an example. We're going to use the Pythagorean theorem to find the missing side. Now, we have to determine before we do anything if the missing side is the hypotenuse or if it's a leg. And the legs always make up the right angle. There's our right angle there. So this is definitely a leg that's missing here. And our hypotenuse is always the longest side. So it's the side opposite the right angle. So I'm going to take leg squared, which in this case is x squared. It doesn't matter which one you put first. You can have the 5 root 7 first as well, plus 5 root 7 squared equals 5 root 13 squared. And if you remember, x squared plus, this gives me 25 times 7 equals 25 times 13. And that gives me, so 25 times 13 is 325. (25 times 7 is 175. I'm going to go ahead and move that over by subtracting the 175. Give us our 150. Here, so x squared equals 150. I'm going to have to do the square root of that. And we're assuming the leg is positive, so we're only going to have the positive root in this case, root 150. Now 150 does break down. So 25 times 6. And you can see the root 25 can come out. Root 6. So there is my missing side. Now we could get a decimal approximation of that. I could do the square root of 150, which in real life, of course, we would need to do. And so you would need to follow whatever directions your teacher gives you. So that is the Pythagorean theorem, just a quick refresher. And we're moving on to the Pythagorean triples. Pythagorean triples are kind of fun. There are whole numbers that end up on a right triangle. The most famous is the 3, 4, 5. And you can actually see if I take 3 squared plus 4 squared, that equals 5 squared, which goes to 9 plus 16 equals 25. So you can see that that works using the Pythagorean theorem. And let's do some examples. So we'll start with part A. And so we have a triangle, and we want to know if it's a Pythagorean triple. Now, the longest side, once again, is always going to be your potential hypotenuse, if this even is. So I'm going to do 9 squared plus 40 squared, and we'll see if it equals 41 squared. 9, that's 81. 40 squared, I believe, is 1600. Let's make sure. 40 squared. And 41 squared is 1681. And you can see this is going to add up to 1681 equals 1681. So we can conclude that 9, 40, 41 are Pythagorean triples. Let's try part B. So we'll take 11 squared plus 56 squared equals 57 squared. We don't know it's equal. We're working on that. 11 squared, I know, that's 121. 56 squared, I don't know. That's 3136, and 57 squared is 3249. Let's see what we get. 31, 36 plus 121 is 3257, which is not 3249. So 11, 56, 57 are not Pythagorean triples. All right, moving on to page 2. And now we're going to talk about different types of triangles. We can identify triangles. The word triangle literally means 3 angles. You can see it there, triangle. And we can describe it using its side or its sides or by the angles that they have. And some interesting facts that we have here is if all 3 sides are the same length, that's called an equilateral triangle. And you can see the word equa already in there. An isosceles triangle is when we only have 2 of the sides are the same length and the third one is not. And a scalene is when none of the sides are the same length. An acute triangle has 3 angles that are less than 90 degrees. So each of the angles are less than 90 degrees. And for an acute triangle, it's going to end up that leg squared plus leg squared is going to be bigger than c squared when we have an acute triangle. For the right triangle, we know that the leg squared plus the leg squared is going to equal the hypotenuse squared. Obtuse means that we have one of the angles is bigger than 90 degrees. And in that case, it'll be a squared plus b squared will be less than c squared. Now, c in each of these cases is always the longest side. So whatever that means in the context of that particular triangle. Let's do an example to determine what we have. Maybe keep that in frame. So let's do part A. 5 squared plus 6 squared. And then we have 7 squared, and we don't know what's going here yet. So I'm going to do 25 plus 36 is 61. So this is 61, and 72 is 49, and we can see this is bigger. This means it's acute. Let's see what happens here. We have 5 squared plus 10 squared Then we have our big question mark. Then we have 14 squared. And I know that's 25 plus 100 is 125. 100 plus 25 is this side, 125. And 14 squared is 196. So this is definitely less than, which means it's obtuse. Distance formula. So the distance formula is actually a variation of the Pythagorean theorem. You can see a right triangle, and it's leg squared times leg squared equals hypotenuse squared, which is exactly what the formula is. The only thing is when we have points like this, we have to do some subtraction with it. And we have a couple of examples down here. There we are. And we're going to start with part A. Anytime there's subtraction in a formula like this, we have to be really careful that we might end up with a minus situation going on there. So just be extra careful. And so here we have the 2 points, 4, 2, and -9 and 5. And I'm going to label this. This is my x of 1, y sub 1, x sub 2, y sub 2 for my formula here. So I'm going to go 4 minus -9. There's that double negative thing I was talking about. Got to be careful. Squared plus 2 minus 5 squared will equal d squared. So I'll have to eventually take the square root. This becomes 13 squared plus -3 squared is d squared. 13 squared is 169, I believe. 13 squared, 169 plus 9. And that gives us to 178 is d squared, which means d in this case is the square root of 178, which is about 78, 13.34. Part A. Let's go and do part B. Here we have the point -10, 3, and 0, -15. Same thing. This will be my first point. This will be my second point. And we're going to go -10 minus 0 plus 3 minus, there's that double minus again. So -10 squared is 100. This becomes 18, right? 3 minus is plus 15 is 18. And 18 squared is 324. So d squared equals 424. All I do is add those two together. And now I need d. D actually is the square root of 424, which is approximately equal to of 424. It's about 20.59. That is the first lesson. Thanks for watching.